So in previous lecture we see that how the pressure changes with respect to depth. Okay, so now we'll understand what is the hydrostatic paradox. So the hydrostatic paradox is, consider there is three shape are there, okay, at constant height h. So the pressure at that location does not depends on this shape. Okay, the pressure here, that is P equal to rho gh, here also pressure that is equal to rho gh, and here also pressure that is rho gh. So there is a fluid inside this shape, here there is a fluid inside this shape, here this is a fluid inside this shape, there is a static fluid. So the pressure is same at the same location. Okay, now if you want to calculate the force, that is P into area A1. So here the area, that is A1, here the pressure rho gh into A1. If you want to calculate the force at that location, that is F2, that is equal to P into area A2. And for object 3, if you want to calculate the force, that is equal to P into area A3. So here we see that this is less area, this is medium area, and this is large area. So here F3 must be higher as compared to this and this. Okay, now next topic, that is conversion of one liquid column to another. Okay, so here there is a fluid, static fluid, and the density of static fluid, that is ρ1 and height h1. Now if you want to calculate the pressure, that is P equal to ρ1 into g into h1. Okay, now there is another density fluid are there. Suppose the density is larger, greater than this ρ1. Okay, now if you want to calculate the pressure, that is equal to ρ2 into g into h2. h2 is the distance from the bottom to the top of the fluid. Okay, so now in that case, both of the case the pressure is same. So for that we can write that ρ1 into g into h1, that is equal to ρ2 into g into h2. So this is the case here. So first case, ρ1 g h1, that is equal to ρ2 g h2. So rho into g, we know that is omega 1, specific gravity, specific weight. So specific weight omega 1 into h1, that is equal to omega 2 into h2. So from here h2, that is equal to omega 1 h1 by omega 2. Okay, and so here same formula, so gg cancel out, so h2 equal to ρ1 h1 by ρ2. And so for this case gg cancel out, and h2, that is equal to ρ1 h1 by ρ2. So ρ1 divided by rho of water, ρ2 divided by rho of water, both side multiplied by rho of water. So numerator and denominator both side we multiplied by rho of water. So from here rho of water, ρ1 by rho of water, that is equal to s1, specific. What is this? s1 means that is the specific gravity. So this is the specific gravity. Okay, so specific gravity, so that is s1 by into h1 by s2, s2 equal to ρ2 into rho of water. Okay, so this is the case here. Now here there is earth and P atmospheric pressure, that is 101.325 kilopascal, and here there is height, this is earth, and P atmosphere, that is h of water. H of water must be greater than. So here if you want to calculate the h of water for water, to calculate the pressure, the h of water will be greater than h of mercury. Okay, so P atm, that is atmospheric pressure, hw, that is height of water column, hg, that is height of mercury column. Okay, so if you want to calculate the height of water column, so we know that rho of water gh, that is the P atmospheric pressure. So omega of water, h of water into P atmosphere, that is equal to P atmospheric pressure. So h of water, that is equal to P atmosphere by omega of water. So atmospheric pressure, we know that 101.325 into 10 to the power 3 kilopascal is converted to Newton per meter square, and density of water, that is 1000, and gravitational acceleration 9.81. So from here you can see that the water column deflection, that is 10.3 meter of water. But if we use the mercury to measure the atmospheric pressure, the column required, that is same here, that is dense, so 1000 into 10.3. So if you want to calculate that, the height will be 760 mm of Hg. Okay, that is equal to 76 centimeter of Hg. Okay, so now we will understand that the unit of pressure, the pressure we know that force per unit area, that is Newton per meter square, or it is known as Pascal, and it may be in kilopascal. So you have to multiply it by 1000, and it may be the megapascal, you have to multiply it by 10 to the power 6. So 1 bar, that is equal to 10 to the power 5 pascal. That is very, very important. Now 1 atmospheric pressure, we know that 101.325 into 10 to the power 3 pascal, that is equal to 1.01325 into 10 to the power 5 pascal, that is equal to 1.01325 bar, that is almost equal to 1 bar. So 1 atmospheric pressure, that is almost equal to 1 bar. Okay, so how 1 kg per centimeter is converted to 10 to the power 5 pascal is there. So 1 kg per centimeter square, that is equal to 10 to the power 5 pascal. So Torricelli's pressure. So Torricelli barometer was invented by Torricelli. So this is the barometer here. So barometer was discovered by Torricelli. So here there is a atmospheric pressure, and there is a H, and there is a small diameter tube inserted on this here. So here the distance is there. This is 1 mm Hg. So 1 mm of Hg, that is equal to torr. So the barometer was first invented by Torricelli. Okay. So just remember this data: 1 mm of Hg, that is equal to 1 torr. Okay. Let's try to understand one question that is very, very important. So the pressure at the base of the mountain is 750 mm of mercury, and at the top the pressure is 600 mm of mercury. If the density of air is 1 kg per meter cube, then height of the mountain is approximately what? So you have to calculate the height of the mountain. So what is given in this question? PB, bottom pressure. So mountain bottom pressure, that is 750 mm of mercury. So 750 mm of mercury, and mountain top pressure, that is 600 mm of mercury, and density of air is given. You have to calculate the height of the mountain. Okay. So what is given in this question? So PB bottom by omega of Hg, that is equal to 0.75 from here. So PV, that is equal to 0.75 omega Hg. So PT, that is equal to PT by omega Hg, that is equal to 0.6. So PT, that is equal to 0.6 omega Hg. Specific weight. Omega is the specific weight. So total pressure, top pressure plus, this is top pressure plus pressure plus this is that is equal to bottom pressure. Top pressure plus pressure, that is equal to bottom pressure. So so here at top pressure at top location of the mountain, so this is 0.6 into omega of Hg. So 0.6 into omega of Hg plus pressure, we know that P equal to rho gh, that is equal to PB, that is equal to 0.75 omega of Hg. So from here rho gh, that is equal to 0.15 omega Hg. So from here H equal to, if you calculate this value will be 2040 meter. So this is approx 2 kilometer. So this is important question. Just try to understand this question. Okay. So this is my handwritten notes. You can download it from the description. The PDF link available in the description. If you have any problem regarding any doubt or any notes related problem, you can directly message me on the chat box. Thank you.